All right, class. Welcome to Screencast 2. Just a reminder, you just watched Screencast 1 on the worksheet, so you can put that away. You don't need that anymore. Please ask me questions about that if you have some. You can email them if they're urgent, or you can just ask me on Tuesday or Monday if you see me. So this one is going to be using that green note sheet that the sub gave you. You're going to have to fill that in as we go along. There will be times during the video where you need to pause and try it on your own. I will remind you about those times, but if you do read the directions on the top, it will tell you anytime you see italicized letters to please stop and write something down. Then after this, you'll be going on to a white worksheet. It's a white piece of paper, front and back, I believe. Please try your best on that worksheet. I want to see how much you can get done. You will not take that home for homework. That will be collected. You have no homework over the weekend except just getting that pre-test makeup stuff ready for Tuesday. Again, come see me Monday if you have questions, or email me with questions, or if you just need help. I know we didn't get to any of those questions at the end, so please come see me if you want me to just look over it. I'm in room 217 during period 1. Period 2, I'll be in the DAH, and 4A, you can find me in the LMC. So moving forward, here is the worksheet you have in front of you, that green piece of paper. Paper. So I'm going to type in this. I'm going to move fairly quickly, so you probably, when I write something down, will want to pause it once I finish. That way you can write it down, but I'm not going to wait like I usually do in class for everyone to write it down. I'm just going to go. So today we're going to be talking about deductive structure. It's about logic and logical thinking, if-then statements. As you can see, we have a lot to cover, so pause it if you need me to slow down, or pause it and rewind if you need to hear anything again. But deductive structure, so what is it? So it's a system of thought in which conclusions are justified by the means of previously assumed or proved statements. Let me go back and fix my typos. So basically, deductive structure is, in other words, just to kind of give you a more clear definition, it's just a way we talk about things, or a way we think about things logically, and how we use previously learned or previously assumed statements. So we do that in real life. We also do that in geometry, which is real life, believe it or not. So you see this a lot when we talk about politics on the news or in person. It's a lot of, well, if this happens, then that happens, or this has happened in the past, so this will happen now, or we know this, so we can conclude this. It's just if-then statements. We use them every single day. So a postulate is what we use a lot of times during these deductive structures, or when we write proofs. So it's an unproven assumption. A postulate is just something that's unproven, but we're all okay with assuming it. Now, definitions we've used a lot already. It's the meaning of a term or an idea. We have the definition of a point, a line, a segment, all that stuff. It is reversible. So kind of the important thing with definitions and postulates is that these are not always reversible, where definitions are. So an example would be, the other day we talked about midpoints, learned about midpoints. The definition was, if a point, line, segment, ray, all that stuff, breaks up a segment or angle into two equal parts, then we have congruency. Or in the case of a midpoint, if a point breaks it up into two equal parts, then that is the midpoint. But that can also be reversible. If something is the midpoint, then it's broken up, the segment is broken up into two congruent points. You see how those go both ways? That's why it's a definition. So real quick, pause the video, italicize. What is the difference between definitions and postulates? If you can't answer that question, rewind. So thanks for pausing. I hope you wrote down something well. I'll look for that, and we'll talk about that on Tuesday. So super quick, what a conditional statement is just an if-then statement. So Move my cursor over here. Switch to red. The P, we use the notation P to Q. So P to Q is the hypothesis. That's what P is. If I could spell, that'd be great. This is the hypothesis, the P. So what we think, if blank, Q is the conclusion. If it rains, I will bring my umbrella from home. That is a conditional statement. Again, what I said, it was, if it is raining outside, then I will bring my umbrella. Or then I will wear my rain jacket. Okay? Or, then I will get wet. There's many different conclusions from one hypothesis. The converse statement. So it's the opposite. So we have Q, then P. We're just switching it. It's just the opposite. So let me get my cursor down here. So it just reverses, if you want to write something down. It reverses the hypothesis and conclusion. And you can see the notation, how it looks. Man, I can't spell hypothesis. Yeah, I can. Oh, I did it again. So it just reverses the conclusion. So an example, I'll do this in blue writing. Example is, if a man is Santa Claus. Hold on, my dog's barking. Alright, sorry about that. So we're going to do an example on converse statement. So the example is, if a man is Santa Claus, then he wears a red hat. Okay, so that would be the conditional statement. It's just a simple if-then statement. Now, the converse is going to be just the opposite. We take the Q, which is right here, then he wears a red hat, and we put that in the front. So, if a man wears a red hat, then he is Santa Claus. And you see how this one's true. So if a man's Santa Claus, he's going to wear a red hat. We all know that. Santa Claus wears a red hat. But if a man is wearing a red hat, then he's Santa Claus. That's not always true. That only is true in one situation. So I could put on a red hat right now. That doesn't mean I'm Santa Claus. So that's the important thing to note, that not all converse statements are true. Sometimes they are when it's definitions, but when it's something like that, it's not true. All right, so moving on. Okay. Just hit backspace on that. All right, so the sample. So I'm going to type it out first, and then I want you to try it. Pause the video and try it. So if the first, do this in blue again. If an angle contains 90 degrees, then it is right. What I want you to do is find the converse and tell me if it's true or not. So go ahead and do it. Pause the video and do that. All right, so if you did it out, you would have got, well, this should have been then. You would have had, if an angle is right, then it contains 90 degrees. And that is true. So that's a definition. So it works both ways. We know if an angle is 90 degrees, it's right. We also know if an angle is right, it's 90 degrees. So it works both ways. So again, number 2, if Mary received a B on her test, if I could spell, that'd be nice, on her test, then she passed. So go ahead and try to write the converse again. Tell me if it's true or false. All right, so you should have got if Mary passes, put this in blue again, if Mary passed, then she got a B on the test. And that is false. Okay, so if Mary passed, she could have got a D, a C, a B, or an A on the test. So this one doesn't work both ways. The converse is not true. All right, so moving on. Let's learn about negation. So Negation, that's just when P turns into not P. So anytime we have a conditional statement with P, the hypothesis, we're saying not in there. So not, so we write it like this. Whoa. Write it like this. It's this line with a P. Again, to make it a little bit easier for you to see, it's that with a P. That's how it looks like. All right, so the inverse. The inverse is when we have something like this. We have that squiggly line and P, and that goes to not Q. So we have not P leads to not Q. The cursor just wants to go in the middle. And the last one is the contrapositive. So that one we are taking the converse and making them both not. So we're literally just combining the inverse and the converse. So we have not Q leads to, if not Q, then not P. All right, so that's how the contrapositive works. Now the chain rule, as you guess, it's something with one thing, then the second thing, then the third. So the first leads to the third. So we have 1 goes to 2, 2 goes to 3, so then we can assume 1 goes to 3. It doesn't have to be 3 things, it could be even more. It's just a follow a chain. So a series of conditional statements that are connected in a logical sequence. So that would be if P then Q, I'm going to type it out, and Q then R. Therefore, so we have P then Q and then Q then R. So therefore we can assume if P then R. See how it's just following the chain. P goes to Q, Q goes to Q, Q goes to R, so we can do P goes to R. Let me erase that from the screen. All right, our sample problems, the last things on here, I want you to find for all this. Let me put this on pause again. Hold on. Sorry about that. My puppy gets real defensive of the house. So for all these, like I'm saying, for the sample problems, I want you to find the converse, the inverse, and the contrapositive for these two examples. So example number 2, gosh, I cannot type today. So for example number 2, I want you to find those 3 things for if you live in Atlanta, then you live in Georgia. So that is a true conditional statement. And for number 3, I want you to do, actually for this one, I don't want you to find those 3 things. I want you to find the chain reaction. So the chain reaction for if gremlins, I know this is funny, grow grapes, comma, then elves eat earthworms. If the second statement is if trolls aren't, or trolls don't tell tales, then wizards weave willows. And the last one is if trolls tell tales, then elves don't eat earthworms. So these 2 examples we will go over on Tuesday. That's it for this screencast. I hope you have a great weekend. Try your best on these 2 examples. Like I said, we'll go over them Tuesday. If you have any questions, email me over the weekend or today. But enjoy the rest of your day and your weekend. I will see you Tuesday. Bye.